Okay, thanks so much for giving me this opportunity. Hi, everyone. My name is Islam Hassan. I'm from Egypt. I work as associate professor for the National Research Center. My particular focus on how to boost the plant resilience against ecophysiological constraints and ecophysiological stressors, including drought and stresses, which are our main concern in Egypt, because, as you may know, the vast majority of the country are desert lands. So today I will be acting frankly as a scientific storyteller to let you know how Egypt is actively shifting toward the smart agriculture in general, and in particular the smart irrigation. By integrating smart irrigation modern systems with remote sensing technologies, we can move very rapidly from the traditional practices to the data-driven decision making, allowing more precise water management under arid and semi-arid conditions. This positive approach helps reduce the water losses, enhances the resources use efficiency, and support the sustainable agricultural development. So let's begin diving into more details. In this slide, we're going to see, in general, the water scarcity in Africa and give more focus on Egypt. As you can see, the vast majority of the continent affected negatively by water scarcity because, in first place, the climate change other effects. Egypt classified as arid and semi-arid country with a limited water resources despite the presence of the river Nile. The situation is severely affected the agricultural sector in Egypt because recently Egypt is suffering a lot from the climate change hazard effects and the limitation in terms of the water resources that coming through the river Nile basin. This is mainly because Egypt, for thousands and thousands of years, depends heavily on the water resources of the river Nile as it is its primary water source, making it very sensitive to any change, including in first place the climate change hazard effects, as I mentioned before. In this slide, we're going to see the main structure of the water resources in the country. As you can see, the river Nile in the first place, and the reuse technologies, the groundwater which is unrenewable, some limited rainfall, around 2%, and the desalination technology, which is very pricey. So this means that Egypt's water system is highly dependent on one source, which increases its vulnerability to any external changes, whether climatic or geopolitical constraint. So, from a strategic perspective, this structure clearly shows that there is a must to improve the water efficiency. This is not option. This is a must for Egyptian authorities in order to sustain our limited water resources, and in the meantime to reclaim more lands for securing more food for the next generations. If we take a look at this situation more closely, we can clearly see that how water scarcity is not just a distant issue. It is already happening around us. In many regions, the soil is drying, resources are shrinking, and agriculture is becoming more challenging year after year because of the climate change. This image reflects, as you can see here, a very realistic scenario where the water is limited and the pressure on the natural resources is continuously increasing. For arid countries like Egypt, this is even more critical because, as I mentioned before, agricultural sector in Egypt depends heavily on the controlled water use under already harsh environmental conditions. So the key question here is no longer whether we have enough water or not, but rather how we can successfully manage the already available water resources that we have. So, after understanding the structure of water resources in Egypt, the key question becomes very clear: how we can manage such limited and highly dependent water resources more efficiently. This is where the concept of smart irrigation implementation comes into. Instead of relying on the past traditional fixed irrigation schedules, we can move forward toward a driven system that allows us to optimize the water use based on real plant needs and environmental conditions. So this kind of transition is not just a technological improvement. This is a necessity for ensuring the sustainable agriculture movement. In this slide, as you can see, this slide clearly shows that the dependent on the traditional methods or the traditional irrigation scheduling is usually based on fixed intervals or past experience or personal experience. This approach ignores the spatial variability within the field and often uh, um, leads to either over irrigation or under irrigation. Another key limitation is the lack of real-time data. Without continuous monitoring and proper quantification of plant stress, as Alvaro mentioned before, decision making becomes delayed and less effective. So that the key message is very simple, that the traditional methods, the traditional irrigation schedule methods that measure the soil and the plant water status can't be enough for sustaining our limited water resources. Uh, when we design an efficient irrigation system, it is important first to understand that there is no one size fits all the solution, because there are several factors must be considered to achieve both agronomic and economic optimization. First of all, the soil structure. Uh, Soil structure plays a critical role because, as you may know, sandy soil, for example, under arid and semi-arid conditions, lose water, so requiring more frequent irrigation regime. The second is the type of the crop, also determines the overall water requirements, as different crops have, every crop has his every different sensitives to water stress and different water use efficiency. So the overall productivity of an agriculture system is not only linked to water availability, but also how we will match the irrigation strategies with the soil characteristic and the crop needs at the same time. If we can move forward, it is important to highlight that the irrigation design impacted by multiple interacting factors, as I mentioned, including the soil type, the crop type, and environmental conditions, including the heat stress and humidity stress, and etc. So this is why the modern approaches focus on integrating these variables. So this question is very important. Why do we need smart irrigation in Egypt? If we ask this question, why do we need smart irrigation in Egypt? The answer becomes very clear. When we look at the reality on the ground, Egypt is arid and semi-arid conditions with a limited natural resources. The country relies on the water resources that comes from the River Nile by 80 to 85%. The agricultural sector consumes around 60 to 70% of the available water resources. So now what makes the situation is more complex is the hidden variability within the same field. As you can see here in this picture, as we can see in this example, different zones within the same pivot respond differently. Some areas are over irrigated, others are under water stress, and only a small portion is actually within the optimum range. So the key insight here is very important. Applying more water doesn't necessarily mean achieving higher yield. In fact, efficiency, not quantity, it is the real goal. And this is exactly why the implementation of smart irrigation becomes essential to sustain our natural resources. So, after understanding all the past challenges that related and the limitation that related to Egypt, we need to know exactly what is the definition of smart irrigation. Smart irrigation refers to an advanced irrigation system that uses sensors, weather data, and modern technologies, including, of course, remote sensing, to optimize the water use. Instead of applying water based on fixed schedule, these systems respond to actual field conditions. For example, soil moisture sensors, uh, evapotranspiration, either from the soil and the plant, and even weather data inputs, such as the rainfall, can be implemented and integrated into one system. This allows the irrigation to be activated or stopped automatically, depending on the real need of the plant. So another important advantage is these kind of systems are well designed and be controlled remotely using either mobile devices or digital platform. So this would give the farmers much greater flexibility. As we move into the practical solutions or the practical side of the smart irrigation, one of the most widely used tools is the installation of soil moisture sensors. These sensors provide real-time information about the water content in the soil, which is essential for making accurate irrigation decisions. Instead of guessing or relying on fixed schedule, farmers can monitor exactly when the soil starts to lose the moisture and respond accordingly. So this allows the irrigation to be applied only when needed, which helps avoid both over irrigation and under irrigation, as I mentioned before. So as a result, we can improve the water use efficiency, support the better plant growth and overall plant production. So soil moisture sensors acts as a direct link between the soil conditions and irrigation management. Another important approach is in smart irrigation. One of the vital components of the smart irrigation is the use of weather-based irrigation controllers. These systems rely on climatic data to estimate how much water is actually lost by plants through the evapotranspiration. Instead of focusing only on the soil, they consider the interaction between the plant and the surrounding environment. The key factors here, such as solar radiation, the temperature, the humidity, and the wind speed, are continuously considered or analyzed to determine the plant's water demand. So based on this information, the irrigation can be adjusted more accurately to match the real environmental condition. So this approach helps us to ensure that water is applied according to the actual crop needs. So weather-based controller allows us to align the irrigation perfectly. Uh, Building on the previous approaches and the previous components of smart irrigation, now we can move to a more advanced concept, plant-based irrigation scheduling. Um, Unlike the traditional methods that focus on the soil or the climatic data alone, this cutting-edge approach directly monitors the plant itself. In other words, Instead of estimating the stress, we measure it at the source itself. So by using such cutting-edge sensors placed on or within the plant, we can track real-time water status and water flow and detect the stress signals much earlier. So this would allow the irrigation system to be optimized not only based on soil moisture, but also on the actual crop response and physiological indicators. As a result of irrigation timings would become more secure. So this approach represents a major shift toward the truly intelligent irrigation technology. As we look ahead, the future of smart irrigation is becoming increasingly connected with advanced technologies, especially as nowadays the artificial intelligence. So AI is already being used in irrigation systems to analyze the weather data and estimate the crop water requirements. But what is even more promising is its ability, its accuracy to predict the future conditions. By integrating the data from sensors, climate models, and field observations, AI can anticipate the plant needs, adjust the irrigation schedules automatically, and optimize the water use within a much higher level of precision. So this means that instead of reacting to stress after it occurs, we can move toward a proactive approach where irrigation decisions are made in advance based on predictions rather than assumptions. Another key components shaping the future of smart irrigation is the use of drones. Drones, as Alvaro mentioned earlier, are becoming a powerful tool in modern agriculture, especially when it comes to monitoring the water use and detecting the stress across large fields. Unlike the traditional methods, they allow us to observe the spatial variability with high accuracy and in real time. So, by using advanced sensors such thermo or multi-spectral cameras, drones can detect the changes in the plant temperatures and the canopy conditions, often before any visible symptoms appear. This means we can identify areas of water stress, soil moisture, variability, or even irrigation system inefficiency much earlier and with a greater precision. So, as a result of the use of this kind of technology, the irrigation can be applied more selectively, targeting only the areas that needs water rather than treating the whole entire field or the whole entire pivot. Um, One of the most powerful directions in smart irrigation is the use of advanced image processing techniques. These approaches rely on satellite imagery and drones and ground-based cameras to monitor the crop conditions at different spatial scales. So instead of measuring water directly, we can analyze the plant responses, such as the canopy cover, the color, the temperature, as indirect indicators of the water status and the evapotranspiration. Using technologies like thermo imaging and multispectral analysis. Advanced imaging transforms irrigation measurements or management into a data-rich, especially a precise system where decisions are guided by real-time field variability rather than random assumptions. So now, bringing everything together, This slide presents an integrating smart irrigation framework. The key idea here is, as you can see, is not relying on only single technology, but combining multiple systems into one intelligent platform. So we start with remote sensing using satellite and drones imagery to track or monitor the crop conditions, estimate the biomass through indices like NDVI, and assess the water loss through the evapotranspiration. This kind of information then integrated into crop growth models such as AquaCrop and CROPWAT, which use weather data and reference evapotranspiration to simulate the crop water requirements more accurately. So the next step here is the use of AI-based decision engine. So here, all these data sources are analyzed together to predict the crop water needs and generate the real-time irrigation recommendation. So this entire system connects with IoT sensors in the field, allowing irrigation systems to respond automatically and precisely based on the actual field data conditions. Now let's take a look at one of the most important tools in remote sensing technologies, NDVI. As you may know, NDVI is an indicator that helps us to assess the health and the vigor of the crops. It reflects the key aspects such as photosynthesis activity and biomass development. What makes NDVI particularly valuable is its ability to detect the plant stress at a very early stage. This is a very important approach. Often before any visible symptoms appear in the field. As we can see here within these pivots, there are a clear variation, a huge variation. Some areas are healthy while others are already under stress. This highlights a very important concept. Within the same field variabilities, not all the parts of the field. So the key insight here is that different NDVI zones corresponds to the different water needs. This means that applying uniform irrigation across the entire field or the entire pivot is not efficient. So instead, NDVI can allow us to move toward precision irrigation, where the water is applied based on the actual conditions, each zone within the field. Another important dimension of smart irrigation is the use of satellite-based soil moisture monitoring. Soil moisture is a key variable for understanding the irrigation dynamics because it's directly linked, reflects the amounts of the water available for the plant uptake. What is interesting here is that today we can measure soil moisture not only from the ground but also from the space. This is now a wide range of satellite missions, forming what we call the constellation of sensors that continuously monitor the soil moisture at different spatial scales. Here, as an example, we can see an example for the powerful operational platform, which has been introduced by FEO, Weibo, which provides open access data on water productivity and evapotranspiration at a global and regional scales. This type of platform allows us to monitor how water is actually being used across different agricultural systems, not only at the field level, but also at the national and continental scales. By using satellite-based observations, Weibo helps us estimate the key variables such as evapotranspiration and soil moisture, which are essential for understanding crop water use and irrigation performance. By the way, I guess the kind of platform are introduced by FEO for free. Here, I would like to present or emphasize a practical example of how digital monitoring can be applied in real agricultural systems using a modern platform called the CropWise. This kind of platforms is not for free, but you have to pay. This one generated and introduced by the world-class company Syngenta. This platform integrates satellite imagery, particularly from Sentinel-2, to provide continuous monitoring of crop performance at relatively high spatial resolution. One of its key strengths is the ability to automatically calculate some indices such as NDVI, NDMI, and EVI. Each of these indices provides different insights. As we mentioned before, NDVI reflects the crop vigor, NDMI gives information about the plant water status, and EVI is useful for analyzing the dense canopy conditions. So this kind of platforms can offer frequent updates, allowing us to track on a daily basis the changes over the time and detect the variability within the field. This makes it a very powerful decision support tool for precision agriculture based on all these given data. Now, let's connect remote sensing directly with irrigation decision making in under arid and semi-arid environments. One of the most powerful parameters we can derive from the satellite data is the evapotranspiration, or ET, which represents the actual water consumed by the crop. It combines together we can combine together the ET with such indices like vegetation indices like NDVI, so we can better interpret these patterns. For example, some zones may require additional irrigation, others may already be optimal, while some areas might even be over irrigated. So this can lead us to a very practical irrigation decision rule. When actual ET is lower than expected, so it may indicate the water stress. So when it is higher, it may suggest over irrigation. And when it is matches expected levels, the system is that means the system is operating very efficiently. Now we came to a very important slide, the challenges in smart irrigation implementation. There are plenty of challenges and constraints that declines the use of smart irrigation technologies. One of the main issues is the sensor calibration. Many systems require frequent calibrations, and over the time, sensors, especially soil moisture sensors, can drift, which reflects the data accuracy. Another challenge is the data uncertainty. For example, the vegetation indices like NDVI may become less sensitive in dense crops like wheat, alfalfa, and so on. And the evapotranspiration estimates can vary depending on the weather conditions, particularly under arid and semi-arid conditions. Another constraint is the cost. Also, this is a major constraint or a major factor. The initial investment in technology, along with the ongoing maintenance, can be a limiting barrier, especially for small holder farmers. In addition to that, the connectivity remains a limitation in many regions under arid and semi-arid conditions. But despite all these challenges, the improving of infrastructure and the implementation and the introducing of modern irrigation techniques, smart irrigation techniques, are essential for sustaining the natural water resources under arid and semi-arid conditions. So, with this, I came to the end of my presentation. Finally, I would like to thank you for your kind attention. I would like to thank Panjiu's team for giving me this opportunity to present today. And badly, I have to go fast because I have a scheduled meeting, so I have to run fast to catch my meeting. Thanks much.